Hey, it's Lee Halliday, and we are talking full stack applications in Next.js. Full stack means you've got your front end, which in our case is React, and your back end, which could be any sort of different frameworks or languages. But we're working in Next.js that allows us to build sort of the full stack of our application from React right back to the Node API endpoints. And when you talk about backend, one of the major, if not the most important thing is where are you going to store your data? And for that, we are going to be looking at MongoDB today. This is the application we're working with. It's a Google map built out in React on the front end that allows you to click on the map and warn your fellow campers, wilderness explorers about these wild beasts that we call bears. So these oversized, overgrown raccoons. And what it does is when you click on the map, it sends that data to the backend, which will pick it up and save it in the database. And that's important because when you refresh the page, you don't want the data that you've entered to disappear. Because let's say you're out in the forest, you encounter a bear, you just say, hold on a minute, let me pull up my sightings, and you click on the location to warn everyone else, and hopefully in the meantime you aren't eaten. So let's get started in exploring what this application looks like. So we are not going to be covering sort of the ins and outs of the Google Maps and React. I've got another video that goes in deep on that, so I will link to that below. But just to give you a quick overview of what we're working with, we're sort of importing our libraries, React Google Maps, React Query for interacting with our backend that we'll be building out. We're setting up all of the sort of initial Google Maps settings. And these two functions here are where we are going to be focusing on. Fetching sightings, so that's retrieving them from the backend, and creating sightings, which means basically capturing that click on the map and sending that to the backend for it to save in MongoDB. We've got sort of some code here that works on an optimistic UI using React Query. Again, I've got another video that goes in deep on this, so we won't cover it. But then we come down to our app itself. This is where the UI layer all lives. We're sort of initializing what we need for Google Maps. We've got our React query calls here. And this is the on-map click that gives us an event. The event has latitude and longitude that allows us to call a function, create sighting, which is what we'll be filling out up here. So if we scroll down a little bit, this is where the map itself is. So we've got our header stuff, our search bar, our locate button. You can click that. It zooms you into where you are. I'm in Toronto in Canada, so it will zoom the map in. You can search, so Algonquin Park. It will bring you up there so you can add your bear sightings. And the main part of this map is basically taking the sightings that the backend gives us, mapping them into markers so that they appear on the map. So that's the UI part that we won't be touching on, but just so everyone's aware of what we're dealing with. So first things first, we need a database to store our data in. Hey, I'd like to take a minute to thank AppSignal, who's partnered with me on these videos. Whenever you're developing an application, you're working locally and you're troubleshooting, debugging, fixing things. But when you deploy that app to your users, you want to know that it's working okay. And typically, I always recommend an error tracking tool and a performance monitoring tool. And often you have to search for those separately, but AppSignal gives you both. It allows you to catch errors and then it reports them back to you via Slack, email, etc. But you can also track the performance. And that tells you if things are responding quick enough, if you're making too many database calls, and all of those sorts of things. So AppSignal works both on the front end in React, but it also works on the back end in Ruby, Elixir, Node, like they mentioned on their homepage. So they give you really nice looking charts that you can customize and edit. They give you detailed information about the errors that are occurring, the stack trace of how you arrived to that error, and you've got some really detailed performance monitoring insights. For example, how many database queries did it perform? And in each request, sort of what was the total amount of time querying the database or manipulating data or doing some calculations, etc. So check them out. It's free for 1 month, but then if you use the coupon code LEIGH, that's LEIGH, you get 10% off for a full year. So thanks again to AppSignal and go and take a look. So I'm going to be using MongoDB. Why? because it's for modern applications, and why wouldn't you want your application to be modern? So that's what we're doing. They've got a free database that you can set up that's more than enough for sort of demos and playing around and whatnot. So I've got that open over here, and we are going to create our cluster. So this is basically just creating our database. We want the free one. Let's put it in AWS. Let's just defaults all the way around, create that cluster. And this will take a couple minutes to get built. So in the meantime, we need to do two other things. Network access. Who can connect to this server from which IP addresses? Because, say I'm deploying to Vercel, it's serverless, I don't know my IP address, I can put in 000, which basically means anywhere. Oops, try again. 0000, anywhere. Oh no, I keep hitting it. 0000, anywhere. Okay, confirm. Sorry, I kept hitting escape for some reason. I don't know what's up. So we've added anywhere. It's not ideal, but in this case, it's, I think, the best we can do. And we need to set up a user to connect to this database. This is where the security is. This is where you'll put in a password that you can't access the database unless you know it. So we'll call our user Sightings, and we will auto-generate a secure password. I'm going to copy and paste that because I need it for later. Just open up a file and paste it in. And what privileges do we want? I'm just going to give it everything, Atlas admin, but you may want to have different database users that have different roles. Maybe read and write to a specific database, but let's just give it everything so that we don't run into any issues with this demo. So we've added the user, sightings and whatnot. We can come back up to clusters, and it's still building out, but what we can do is connect to it. Not yet. So let's come back to that as it's generating itself. Oh, done. Cool. So let's click this, and we say the middle one, connect to our application. And the important thing is it gives us this connection string. We're going to copy that, and we're going to use that in coordination with this password here. And we're going to put that locally into a .env.local file where we can store local environment variables. You don't commit this file. If you were to deploy to a server like Vercel, you would set up your environment variables there as well. You don't want to put your passwords into your Git repository. So we paste this in, and we can actually just get rid of this DB name here on the end. And we need to replace where it says password with what we had copied and pasted. Like that. So I can just close this file now. It's not needed anymore. And this should allow us to connect to the database. We can test it out by going into Compass, which is the Mongo Mac client and Windows client. And we can paste that in. We can connect to it. And our database cluster has these databases in it. So we want to create a new one for sightings. So we'll just call it sightings. We need one collection. Collection's like a table if you're used to MySQL or Postgres or whatnot. So we'll give it the same name, sightings everywhere. We can click into it, click into our collection, and there'll be no data. That's what we're going to be working on in our app, but at least we know we can connect. So coming back to our application, if we think about the front end, whenever you're building an app, it's always sort of full stack, right? The front end communicates to the back end, which communicates to the database. So if we start in the front end, why don't we start with adding data? Because right now there's no data in there to actually show, so we won't know if it's working or not. So when this gets called, I'll just console.log out the data that's passed so that we can see what's going on. And I'm going to close this one because that's a hosted one, and I am going to start. Is it start or dev? Dev. I'm going to start the Next.js application. It's loaded the environment variable from .env.local, which is perfect. And we can pop open our local map, which will hopefully render, but with no data. So if we open up the browser console, click on the map, we can see that the data we're being passed it looks like this, latitude and longitude. So that's what we want to basically take up and post to the server, send to the backend. So we will do that by using fetch. So fetch isn't just for reading data, you can write it as well. And the way you do that is you say const response is await fetch. And where are you going to post the data to? So we are posting to API Sightings create. So Next.js gives you API pages, which allows you to build a backend sort of side by side with your Next.js frontend. But by default, fetch does get requests, which is when you're reading data. So we want to send data, which is a post, when we're creating new records. So we say method is post, and we need to also say that what type of data we're sending up. So you do that via the headers, and we want a content type of application/JSON. That's the MIME type of what data we're sending up. And then the data itself. So this is the body, and we're going to have to convert this into a JSON string, but first, let's just look at what we're going to send up. We're going to send up sighting, and then whatever was in this variable here, so latitude and longitude. So sighting data. Take this object, which you don't want to post directly, you want to stringify it first. Stringify, just like that. So what we can do is we can wait for the response to be converted into JSON, and then we have access to whatever the server responds back to us. So we're not actually going to do anything here, so I'll just leave it as is, but if you wanted to return it, I guess you could. You could return data.sighting, which is what the backend's gonna send back down to us. So let's get rid of the console.log, and let's try running this code again by clicking on the map. And we'll specifically go into Network tab and we'll say API Sightings. So we can see that we posted to the backend, and we sent up the request headers like application JSON like we set. And then our payload here, which is the body, is this sighting that we sent up. So now it's time to hop over to the backend. So this API Sightings create, and it's time to receive this information that the front end has sent to us. So the way we do that is we can console.log, but it's the request.body. So in Next.js, you're asked to export a function that receives the request details and that's given a response, basically what to send back to the front end that's requesting or sending data to this backend API. So if we look at the rec.body in the console, if we click on the map, it's not this console where it's going to show up. This is happening on the backend, so on the server. So we would actually pop down to our terminal here. And we can see that we're receiving a sighting which has a latitude and a longitude. So if we come back here, why don't we take that and put it into a variable? So we can say const rec.body, and we can do some destructuring. So sighting consists of latitude and longitude. And this is what we are going to want to put in the database. But in order to put that in the database, we need a connection to the database. So I'm already importing a function that we're going to implement in utils database called connect. So if we pop over to utils database, we've already imported our Mongo client, but we need to take that and create a new instance of it. So const client equals new Mongo client. And the first thing you want to pass is that database URL connection string. You access environment variables using process.env and then the name of it. And we can pass in some additional options as well. So the ones we want to pass are use new URL parser. To be honest, I don't know what this does, but who doesn't want the new parser? I do. Don't know what it does, but same thing with use unified topology. I've also seen this recommended. Also don't know what it does, but I want definitely things to be unified. So with our client in place, what we're actually going to export is a function called connect. So let's define that, async function connect. So what this function is going to do is create a connection to the database, to the client up here, if it doesn't already exist. This code may receive and respond to multiple requests, and there's no point reconnecting to the database each time. We can hopefully reuse a connection to sort of save on the number of connections made, the time, etc. So what we're going to do is we're going to say if not client.is connected, we will await client.connect. So if it's not connected, connect. That's what we're saying here. And then what we want to do is access the database. Because remember there were like 4 databases, but specifically we had one called Sightings. Let's return a database to that Sightings one specifically. So you say db, give me the Sightings, like this. And now we can return the database and the client. For whoever's calling this connect can access both if they want to, one or the other, etc. So we need to export this now, connect, and that's it. Hopefully it will work. We'll check in a second. So if we pop back over to our create, we can now, since we've already imported it, say, give me the database, await it because it's asynchronous, connect. So with this, we should be able to connect access to the database where we can insert this new sighting data. So that's what we're going to do right here. What we're going to be doing is saying, whatever operation we're doing, inserting, will give us a result back. It's a promise base, so we're going to await it, and we'll say, db, what collection are we using? We're using the sightings collection. That's like the table. And what we want to do is insert one record. You can multi-insert, but we've only got one to insert, so that's what we're doing. So how are we going to store the latitude and longitude? We'll store it in a field called location. And this is a special data type called GeoJSON. Whenever you're storing sort of data that has to do with maps and positions on maps, GeoJSON has different types of data like polygons, lines, and the one we're working with is called a point. So we'll say type point, and a point consists of coordinates. It's just one point on the map. So coordinates is an array of longitude first, very important, and then latitude second. If you mix them up, it's going to show up some weird place on the map. We don't want that. And let's store when we add this as well. So created at will just be the new date. So current timestamp. So with the result back, why don't we take a look at what it's giving us? And the way we access that is we can just console.log, it's my favorite way of debugging, result, and result has something called ops, basically the operations that were performed. And because we only had one inserting a record, we will access the first one. And if it worked as planned, that should be the new sighting that was inserted into the database. So let's come back to the client. Let's kick off a call to the backend. Let's go here and console.log. We can see this location that was just inserted. It's coordinates sent up from the front end via that function we just implemented. And then an ID that Mongo gives us. So if we pop over to MongoDB Compass, we can now refresh this and we can see the data that we've inserted in here. And next thing is to come back to the backend, and what do we want to do with the data that was just inserted? We probably want to return that as JSON to the client. So what we'll do is we'll say the sighting was the result ops 0, the first operation, like that. So in HTTP requests and responses specifically, there's status codes. They all mean different things. 200 is sort of the default here. So we'll set that for a second, but 200 means okay, but 201 means created. And I think that's what we'd want to respond with because we just created data. And I think we're ready to go, but we've only handled the happy path. What if everything works perfectly? There's no mistakes in this code, right? We need to handle what happens if things go awry, if things fail. So we'll wrap it in a try-catch. And if there's an error, what we can do is we can respond with a status of 500, which means server error, and JSON that maybe says error, unable to insert sighting. Sorry, gotta say nice. Gotta be nice and gotta be Canadian with that sorry. So we'll take this happy path code and we'll copy it up into the try. And with that, we're good to go. So now, if I go to the client, I click, it adds the bear for a second, disappears. We'll fix that in a second. But every time it does that, we are inserting data into our database. So we got 2 sightings now. Next step we need to do is implement the part of the front-end code that fetches the sightings from the backend. So that's this function here that's just returning an empty array currently. So what we want to do is again use fetch, so const response await fetch, to grab the data from API sightings. And we don't have to say a method because get is the default, which means that you're asking for data. We don't need to send a body because there isn't one. So that's it. We're good to go. We'll get our data by converting the response to JSON. And then let's console.log it to see what it looks like. So if we were to reload the page, console.log, here's what we got. Sightings, an array, an empty array. So why is that? Because we haven't yet gone to the backend and implemented it. I'm just returning a straight up array. So we need to do the same sort of thing. We need to try some happy path code, catch an error, respond if it fails. So res.status of 500, res.json of error, unable to fetch sightings. Sorry. And then let's do the happy path code. So we want first this connection to the database. So const db await the connect function to give that to us. And then using the database, we can get some sightings. So sightings is equal to await. So database, which collection, which table? Sightings. Which records do we want to find specifically? Let's just get them all. So we just call find like this. Here's where you could limit it. Maybe the client would send up the user's coordinates and you want to limit it to only sightings that are near the user, maybe within 10 kilometers. But let's just leave it find everything, and then we'll convert that to an array because that's what we want to work with. So if we were to console.log this, take a look. Remember, this is the backend, so refresh the page. Backend code here. Here are our 2 sightings. Perfect. So what we need to do is basically just take these sightings and return them as JSON. So sightings, just like that, it will pop this in and we're good to go. If you want to be explicit, you can set the status of 200, but that's the default, so it's sort of redundant there, but that's fine. So with this, we are good now to pop back to the front end and take a look at what it's returning to us. So now we've got the sightings on the front end. But there's a little bit of an issue. They're not in the right format that the front end's expecting. The front end wants, let me show you what it wants. It wants each sighting to look like this. So an ID, longitude, latitude, and created at flat. But if you look at the data we're dealing with, you've got location, coordinates, it's not flat. There's an underscore ID, not an ID. So we want to convert it into the structure that we want. And anytime you're basically taking an array and you're converting every single element into a new version of it, that's sort of the ideal map candidate. So what we can do, why don't we just destructure sightings from this data, and then we will return a mapped version of those. So we'll say sightings.map. Each sighting will be a new object. So because it's an object, you can't just do that. We need to say parentheses, we're returning an object. And then we build the new data structure that we want. So the ID is equal to sighting dot underscore ID. The longitude is sighting dot location dot coordinates, the first one. Latitude is sighting dot location dot coordinates, the second one. And then we've got our created at, which is just sighting dot created at. So now that we're returning the response that the front end is expecting in the right format, we should be able to pop back here and actually see our locations on the map, which is exactly what we're seeing. We had 2. We can refresh. They're loaded from the back end. We can add some new ones on the map. Boom, boom, boom. And it's all looking good. So I didn't touch too much on this, but I'm doing some optimistic UI updating here so that I'm actually showing the sighting before the backend has even had a chance to respond. I've got a video that covers how to do this with React Query in a detailed way, so I'll link to that because it's a good thing to do, but it's too much to cover in this video. So I will link to that below. So with that in place, basically we're done. Let me show you back to Compass. One cool thing, we've got all our data here. You can go to Schema and say analyze it, and they actually, because it understands the type of GeoJSON format I used, it shows us on the map where the positions are. One thing that's really neat to add is validation. So in Postgres, for example, or MySQL, relational databases, you have to define the schema. Mongo's a little bit freeform. You can put anything you want in there, but they give you a way to validate the schema. So I actually wrote an article on this recently, MongoDB GeoJSON Schema Validation. And I'm actually going to copy this validation string. And what this does is it basically tells the database to enforce the data looking a certain way. And what we can do is we can say, we're going to require a location, and the location looks like this. It's got a type, it's got coordinates. What do the coordinates look like? What are their minimum and maximums, etc. The only thing this one's missing is we actually have created that as well. So we can just add that here. And it is a BSON type of date. And coming down, it tells us all our data is valid. There's no documents that are failing. So save that, and now we're protected. The data we're inserting will conform to this schema, and we can make some assumptions about what's going to be there and what's not going to be there. So just to cover and talk about what we looked at in this video, we built out a full stack application. We implemented the front end that basically communicates to the backend via HTTP requests using fetch. And then we built out the backend that receives those requests, talks to the database via the connection that we set up to MongoDB, and it either reads data, as is the case here, or it inserts data, as is the case here. And with that, we've gone from front end only to a full stack application that will record the sightings so that when the user comes back, they can remember where the bears are. Hope you enjoyed this video. Take care. Bye.